Hello, data voyagers, data explorers. My name is Igor Alcantara, and we will talk today about a very, what I think, very useful, interesting topic, the Fourier series and transform, but applied to data analytics. So I will start by explaining a little bit of the theory, but don't worry, I'm not going to get tip into Fourier, but just an overview so we understand what it is, what are the different pieces, and why do we use it. Then I'll display a problem, and then we'll see how we can solve that problem using this technique. So without further ado, let's go ahead. So this is the same application we explored in my previous demos, but now I have different charts. So this is basically for the last 24 months, based on the data we have, a kind of a sales trending. That's what I'm trying to understand. So I have per day, what is the sales? But what is the trending of my sales? There's too much noise into this, and then I cannot see any trending because sales they go up and down every day as expected, and I don't see any trending. Well, maybe because this is too granular. So let's take a look at that same data, but a group by month. So this is by month, and I'm showing the year so we can see month over year. And we kind of have, it's better, but we have a kind of similar behavior. So sales goes up and down generally, and it goes really down here in April, up, but it kind of like it dropped in the last month. But I'm not sure if there's actually a trending or if there's just one of these pieces where it goes down, but it will go back up after. So I don't see any trending. The reason for that is I'm analyzing time data. This is sales over time. So I'm analyzing time data. And when we analyze in time data, because there's a lot of variance expected during the time, like sales, again, each day they go up and down, that doesn't reveal me the trending on that data. So what I need is to remove the noise and focus only on one thing, the frequency. Now, let's talk about this French mathematician, Jean-Baptiste Fourier. So Fourier came up with this brilliant, very interesting mathematical concept that we use in many areas, including image recognition, a lot of AI stuff. Pattern recognition is another thing. So I'll summarize a lot what it is. So Fourier said that we can write any function. And when I say a function, I'm mentioning basically a mathematical function that we can draw a graph when we plot the different inputs for the function. So he said we can write any function by basically combining the sine and cosine function. But of course, there's a challenge to actually get the sine and cosine function from any function. So we have like a sine function here. We have a cosine function. We sum those functions, and the sum those two functions, we can then rewrite any existing function. So I can have things like this graph right here. Let me click Edit Sheet. Let me expand it a little bit so we can have a better visualization of this. There we go. So we have different types of functions like the square wave, sawtooth wave, triangle wave, semicircular wave. So we can rewrite these functions using sine and cosine. Why is this important? Well, it's like I give you a dish, and then from the dish, you get the recipe. That's basically the beauty of this transform, or the series, actually, the Fourier series. Now, there's a tool that we use to get to the Fourier series, which is the Fourier Transform. And it's not too complicated, but it will be a little complicated and long to explain in this video. But basically, what we want to calculate at the end is the magnitude. And the magnitude is calculated based on two different pieces that we have to put together. We got those two pieces together, and then we got what we need. Those are the two parts. Remember when I talk about sine and cosine? So we have what we call the real part, which is basically the amplitude. Amplitude is the height of the wave, is the amplitude of the cosine function. And we have the imaginary part with the amplitude of the sine function. And these are the formulas. I place it here, but I'll show you how to do it in Qlik in a minute. So if you combine those two, you get what we need, which is the magnitude. The magnitude, it will be basically the square of these sum by the square of the imaginary part, and then we sum the squares, and you take the square root of that, and then we have the magnitude. And of course, we square them before summing, just in case if we have negative and positive, they don't cancel each other out. So then we have the magnitude, and the magnitude is what we're going to plot. Okay, so that's basically what we need. Another thing is, if you see there's a term here called the K, that's what we call the frequency index. So that's basically represents the number of rows that you have in your record. And I'll show you a script. I'm not going to write the script because that will make this video too long. As usual, I have the script already written, and then we go over and explain it for you. So my source table, where I have my sales data, it's the same that I used in my previous video. So this is a basic table I call fact orders. I got like the order date, I got the order ID, the sales amount. It's very basic. And I just want to, I have like a timestamp field. You don't have to have a timestamp, it could be a date, but I wanted to do as a timestamp, and that's the time portion that I'm using. So basically I need two pieces, two inputs, which would be the date, the time portion, and the actual number I'm analyzing, the input for my function, which is sales. And in this case, I'll call line sales amount. Now let's come here. So I'm taking the number of lines in my fact table as my n. So my n, it's basically how many interactions I will perform. And then basically I'm creating a table here that has one row per row. It's basically an index table. Starting with 0. So that's why we're doing this row number -1, because I want to start with 0. There we go. Then I'm loading my temporary table with the inputs that I need, which is, again, time and sales. I just added a small where clause here because I don't want to load all the data. I just want to load the last 24 months. There are reasons for that, because I don't want things that happens way in the past to actually interfere anything in my data. So I'm only loading the last 24 months. You don't necessarily need that, because this will kind of take care of that kind of automatically. And then look at this. I'm doing an outer join, so basically a join to my list of values, my list of K values. So I'm creating a Cartesian product here for each one value of K. So K is like 0, 1, 2, 3. For each one of those, I'll get all of the orders. Or we can reverse the analysis. But for each order, I'll get a list of all of these rows. So we're creating a Cartesian product. So then we'll get every single possibility of point in the graphs. Because I don't know the parameters of my function, that's the beauty of the Fourier transform, that will calculate that for us. That's basically it. So then I have this table, which is the input for my Fourier transform. So this Fourier transform, I'm basically applying these formulas So look at this. What is the real part? Basically, it will be the value times the cosine of this. So that's my formula that I'm doing for the real part. So the sum of sales, that's my input, times cosine of 2 times pi times k times the time portion divided by n. That's basically this formula. Do I have to memorize that? You don't have to memorize that. You can copy and paste and apply to your use case. Okay, the same for the imaginary. It's almost the same, but instead of cosine, we're doing a sine. And the magnitude will be basically this square times this square, and then a square root of that. Just like we saw here, I just had to apply the formula. Again, you don't need to memorize any of this. I'll provide you this piece of code, and then you can simply apply to what you need. And then we'll run this. I'm not going to run it because that'll take some time. Let's jump right to applying this. Now, great. Now I have the magnitude of the combined function. So basically, what I did is I inputted this function right here, got the value of that function. In terms of time data, what the Fourier transform does, and this is very, very important. I need you to pay fully attention to this. What the Fourier transform did here is it converted the time to a frequency. And that's how we get the trending, by removing the noise. So again, the Fourier transform converted the time to a frequency. Now let's do another graph here. Let me expand this more. Let's come back here and let's do a line chart. And then as my dimension, I will add that k value, which is basically my frequency index. And then my y, instead of doing the sales, I'll do the magnitude, which is removing the noise is just the frequency of the sale. So I'm going to come here, and I'm going to find magnitude. It doesn't matter, but I can do like the average magnitude. There we go. So look at this. This is much clearer to understand than this, because then we actually see the trending. I don't know what date each of these numbers correspond, but that's not the case because it's not time anymore, it's frequency. But I can see the trending. So my sales were trending down, but then they started to recover. Now they slightly trending up. That's what I want. So if you combine this knowledge with the actual graphs that you have, you can compare it. And look at this. It looks like we're dropping, but actually the trend, it's going up. So remove the noise, and you now see the trending. That's part of some of the techniques for time series, by the way. So it decompose when you got the trending time series using Fourier Transform in Qlik script. Again, I hope you find this useful. And if you find this useful, share with your friends, share in your social network, and make sure to subscribe to Data Voyagers and send us recommendations or requests of things that you like us to present. See you on the next video. Goodbye.